So let's look at a final example for this class. Now this question says the three forces F1, F2 and F3 acts at point A on the hanger below along a specified direction. Determine the x and y component of each force, and B says the resultant force R in vector form. Alright. So first of all, let's get the x and y component of each force and then the resultant force. Alright, so first things first, so we have three forces here, F1, F2 and F3. F2 has no problem because theta 2 is 35 degrees inclined to the horizontal. But F1, we were not given the angle, instead we were given this. Alright, next up, F3, we're given this whole thing. So let's analyze F1. Let's analyze F1. Let's analyze F1 a bit before we start solving. For F1, we're given this triangle here. For this triangle, obviously, here is the right angle. Let's assume this as theta. This same value will be what I have here as theta, because we are saying that this is a triangle. Alright, this is a way of representing this. So we are saying, let's take here as theta the angle of inclination of F1 to the horizontal. You assume here to be theta. This same value comes here. Okay, the triangle you see here is same as here, here, and here, but it's just being brought out and represented in this form. So if we've gotten here as theta, and we're saying here and here the same thing, let's get sine theta and cos theta. From here, sine of theta, so this is 1, so sine of theta 1, sine is opposite. Okay, so if here is 4, here is 3, let's get this point here. So if here is 4 and here is 3, let's get this value here. To get this value here, we'll have to use Pythagoras theorem. So let's get this side. What's this value here? Let's call this x. We can get this using, since this is a right angle triangle, we can get the value of x using Pythagoras theorem. Or we can see that the square of the hypotenuse is equal to the sum of the square of the other two sides. That gives you 3 squared plus 4 squared. 3 squared gives you 9. 4 squared gives you 16. So x squared is equal to this 2 gives you 25. So x becomes the square root of 25. Of course, that's equal to 5. So this value here is 5 using Pythagoras theorem. Alright, so we now have 3, 4, 5. Using sine theta 1 becomes sine is opposite here, 3, all over hypotenuse here, that's 5. So this value of sine theta 1. Also, let's get cos theta 1. Cos is adjacent. Adjacent of this angle is 4, that's 4, all over hypotenuse of this triangle here is 5. So I'm having this. So with this now, I've got the value of sine theta 1 and cos theta 1. Let's note this somewhere. Where do we note this? Okay, so let's say sine theta 1 is equal to 3 over 5 and cos theta 1 is equal to 4 all over 5. Alright, so we are done analyzing this. Let's now analyze this one here. So let's analyze F3. Now for F3, the same thing goes. You have that's this line here. We have F3 coming this way. You have F3 this way. This is F3. This is the you have this one here, which is this line. This line here. Okay, we have some coming down, which is this. Alright. So let's get from here, since no angle was given, we'll also assume this angle here. call this theta 3. This is theta 3 is the angle of inclination of F3, as you can see, to the horizontal. From this now, if I watch this closely, we can get a triangle of this form. So this is F3 equal to 800 Newton. We can get a triangle of this form here, where, okay, let me write this here, F3 equal to 800 Newton. Now observe, from here to F3, from this line to F3 is 0.1 plus 0.3, that gives you 0.4. So from here to here is about 0.4 in meters, okay, or 0.4. Okay, you can use the meters if you want to, that's 0.4. Also observe the distance from here to here. What will it be? Distance from here to here, from the triangle, because this is theta 3. Distance from here to this point, what will it be? We're going from here to this point, what will it be? From here to here is 0.4. From here to here is 0.2. Hence, from here to this point here, which is same as here, has to be 0.2 plus another 0.2 to give me 0.4. So from here to here becomes 0.4 minus 0.2, which is 0.2 meters. Alright? From here, which is this, from here to here gives you 0.2 plus 0.2, which will give you your total 0.4. Alright? Or if you want to use mathematical sense, you can call from here to here as x. So now have that x will now be equal to 0.4 minus 0.2. The same thing, so 0.2 meters. So I now have this. From here, let's get sine theta and cos theta. So I'm having this here. This is 0.4, 0.2. This is my hypotenuse. Let's get the value of the hypotenuse. Let's call this x. So I'll have that x squared is equal to this 0.2 squared plus this 0.4 squared. So x squared is equal to, let's get these values. So if I punch this, 0.2 squared gives you 0.04 plus 0.4 squared gives you 0.16. So x squared is equal to 0.2. Yep, 0.04 plus 0.16, 0.2. So x is equal to root 0.2. X is equal to the square root of 0.2. That's 0.45, 0.45 meter approximately. I'm using here as 0.45. Or you can use square root of 0.2 if you want to. Okay, whichever way is still correct. So let's use 0.45. Alright. If this is true, to ensure uniformity of decimal places, this is one decimal place. So I'm going to use 0.5 here to ensure uniformity of decimal points. So I'm having 0.45 as the value, or better so to still use square root of 0.2. Still correct. So whether you choose to use 0.45 or 0.2 is still correct. Alright, from here let's get sine and cos of theta. Sine theta 3 is equal to, here opposite, 0.4 all over hypotenuse root 0.2, and also cos theta 3 is equal to cos is adjacent 0.2 all over hypotenuse. Of course, this should be in meters. Root 0.2. Observe, I didn't include the meter because they'll cancel out. Okay, 0.4 meters all over 0.2 meters. Meters will cancel out, so don't worry about it. So I'm having this. Alright, let's write down this value. We said sine theta 3 is equal to 0.4 all over root 0.2, and also cos theta 3 is equal to 0.2 all over root 0.2. Alright, so we have this. We can now proceed to solving this question. So your first task is to get, so for this one, we already have the angle here, so it's not a problem, you can easily resolve. For this one here, there was no angle, so we did this to get the sine and cosine of this. This one, so there was no angle, so we did this to get the sine and cosine of this. So we are done with the analysis. We can now proceed to solving this question. Alright, so let's start with summation of horizontal forces. So summation of horizontal forces. So sigma fx is equal to, alright, so let's start with F1. Now observe that all the angles are inclined to the horizontal. This one is inclined to the horizontal. This one is inclined to the horizontal. So we don't have to stress ourselves. That means Fx has to be F cos theta. Alright, let's start with F1. F1 is here. Resolve this one horizontally. It will now lie in the negative x axis. We've discussed this. This is quadrant 2. So it becomes negative x axis. Hence it becomes negative of F1 cos theta 1. F2 is this. Resolve this one to the horizontal axis. Becomes, this is positive x axis. It becomes plus F2 cos theta 2, which in this case theta 2 is equal to 35 degrees. And then finally we have F3. F3 is this one here. Resolve F3 horizontally to come this way. This is quadrant 4. Quadrant 4, x is positive. It becomes plus F3 cos theta 3. Alright. With this side, let's now proceed to impute values. This is equal to minus F1 500 minus 500 cos theta 1. Cos theta 1, the value is 4 all over 5. So look at the way I spell this, okay? Cos theta 1 is 4 over 5 plus F2. F2 is 600 cos theta 2. Theta 2 is 35. So it becomes cos 35. Then finally plus F3. F3 is 800. And then cos theta 3. Cos theta 3 is 0.2 all over square root of 0.2. So we have this. Alright, let's get the calculator and get this value. So this should be minus 400 minus 400, because 5 here 1, 5 here 100 times 4, 400. Let's get this other value. So let's punch plus, let's see 600 cos 35. That's about 491.4912 plus, let's see 800 multiplying in bracket 0.2 all over square root of 0.2. So this value is about 357.7709. Please make sure you punch this correctly. You have this value 357.7709. You have that value. Please punch it correctly. So therefore, the summation of horizontal forces is equal to minus 400 plus 491 0.4912 plus 357.7709. This is about 449.26 Newton R. Alright, so this is like the value fx 449 plus 26 approximately. You actually have 2621, but approximately in two decimal places is 26 Newton R. Let's get the summation of vertical forces. Let's look at the summation of vertical forces. Notion of vertical forces. Alright, so sigma Fy is equal to F1, resolve F1 vertically. F1 we said is in quadrant 2. Resolve this vertically, that's positive y. So it becomes F1 sine theta 1, of course. Sine theta 1. For F2, resolve F2 vertically should be positive. So plus F2 sine theta 2. And then F3, resolve F3 vertically, that becomes negative of y. This is in quadrant 4. So minus F3 sine theta 3. So I have this. Alright, so this is now equal to F1 is 500, it becomes 500 sine theta 1 is 3 over 5. Okay, plus F2 is 600 sine theta 2. Okay, so that's sine theta 2 is 35 minus F3 is 800 sine theta 3, that's 0.4 all over root 0.2. So I have this. Alright, so we have these values. Let's impute value. So this is equal to, if I solve this one here, of course, give me 300 plus, get a calculator and punch this. (600 sine 35) 344.1459 minus 800 into 0.4 into square root of 0.2. That's 715.5418. Alright, so sigma Fy is equal to, let's get this, 300 plus 344.1459 minus 715.5418. That gives you minus 71.39. So in today's office, you give you 40.40 or just 4 Newton J. So I have this. So this is value of sigma Fy. Alright, so let's now get the resultant in vector form. Alright, so let's answer the question there. The first question says, find the x and y component of each force. So let's start with say for each force. So let's start with force 1. For force 1, yeah, for force F1, okay. For force F1, let's get the x component. The x component, same as the horizontal component, right? The x component is equal to F1, okay, we said it's negative, So it becomes minus F1 because it's in this quadrant, so minus F1 cos theta 1. And we had that as minus 500 cos theta 1. We said it's 4 over 5, 4 all over 5, and this is equal to minus 400 Newton I, if I want to. Alright, so that's it. So this is x component of force 1. Let's look at the y component. Y component of force 1. That's equal to, of course, resolve this vertically. That becomes F1 positive sine theta 1. And that will be equal to F1 is 500 sine theta 1. Sine theta 1 is 3 over 5. Yeah? 3 over 5. And that's equal to, this will give you 300 Newton J. So we've gotten the x and y component of force 1. Let's now do the same thing for force 2. So next up, for force 2. For force F2, the x component should be positive. That becomes F2 cos theta 2. And that's equal to F2 is 600 cos theta 2 is 35. Let's see 600 cos 35. Punch this up. 600 cos 35. 491.49. That's in 2 dp. 2 decimal places. So I have this. The y component of F2 this way should still be positive. So positive F2 sine theta 2. That should be equal to 600 sine theta 2 is 35 here. So 600 sine 35. 600 sine 35. This is equal to 344.15 approximately Newton J. So we've got the x and y component for force 2. Finally, let's get x and y component for force F3. For force F3, we have that the x component F3, resolve this horizontally, is positive. So we have F3 cos theta 3, and that's equal to F3 is 800 cos theta 3 here is 0.2 all over root 0.2. So if we punch this, what do we get? 800, that gives us 800 into 0.2 all over root 0.2. 357.77 Newton I. So I have this 357.77 Newton I in 2 decimal places. The y component of F3, if I resolve this way, should be negative, first quadrant, so minus F3 sine theta 3. That's equal to minus F3 is 800 sine theta 3 is 0.4 all over root 0.2. So we have this. That's equal to, that's now equal to minus 800 all over 0.4 all over this. That gives you minus 715.54 Newton J. Alright, so this is how we get the x and y component for each forces. We're done with this. let's do the B part. The B part now said, let me check my question again. The B part says the resultant force R in vector form. So we said R, they called it R, not FR. So I'll use what they said. They said R there. So say R is equal to alright, the resultant force R. Now observe they called it R, not FR. So I'll go with what they wrote there, R. So I'm using their R, which is R is equal to the same formula, sigma Fx plus sigma Fy. That's equal to sigma Fx is 449 points. Check the point again. 449.26 Newton I. Sigma Fy was minus 71.40. That's 4 Newton J. So we have it. Alright, factorize this. We have that R, okay, is equal to 449.26 I minus 71.4 J all in Newton. Alright, so this is the answer to that question. Alright, so this is how you solve that question. Alright.